Year 2026. The return landing to the surface of the Moon had just been completed when ESA spotted a new discovered asteroid in the inner solar system by pure luck with the Bepi-Colombo spacecraft. Asteroid was almost impossible to spot from Earth, with the Sun being as bright as it is. After some months of research, a discovery was made that the asteroid has a 30% chance of colliding with Earth in 2031. Fortunately, the asteroid was detected just in time to develop and launch a successor to the DART mission to redirect the asteroid. That was obviously pure fiction, but still very realistic idea. It's important to think how we can protect our planet from asteroids and comets. There are different sizes of asteroids. Most smaller ones would just burn up in the atmosphere, but some could take out a city, a continent, or even cause a mass extinction event, killing just about everything on Earth. That's where NASA's upcoming DART mission comes in, short for Double Asteroid Redirection Test. The mission has an impactor to hit a moon of an asteroid while the effects and impact will be monitored from Earth. All this is to see how plausible it would be to change the orbit of an asteroid, however slightly. Oh, by the way, I'm Mikko, the host of Deep Dive here on the Total Space Network. Let's get started. DART is the first test mission from NASA for planetary defense. As it stands right now, the Earth is defenseless against from any stray objects impacting our planet. But DART hopes to prove that we are not entirely doomed. We all know how the era of dinosaurs ended. Dinosaurs didn't have a space program. They didn't even know about the asteroid that came to be their doom. Originally planned as two separate strategies by both ESA and NASA, each space agency had planned independent missions to test asteroid deflection, but agreed in 2015 to combine the strategies. The mission AIDA, or Asteroid Impact and Deflection Assessment, was agreed and set to launch as two independent spacecraft working in synergy. AIM spacecraft would have been launched by ESA in December of 2020 and would have orbited Didymos, studying the surface and asteroid composition, as well as monitoring its moonlet and the effect the impact had on the moon's gravity respective to Didymos. However, the AIM spacecraft was cancelled. As a result, the findings of the impact will have to be studied from ground-based telescopes here on Earth. The binary asteroid Didymos is the selected target for the DART spacecraft, with the main asteroid body being around 780 meters across. It's not an ideal target for DART, however its moon, Dimorphos, is around 160 meters, which is the typical size of an asteroid that could pose a threat to Earth. First discovered on 11th April in 1996 by the University of Arizona using the Kitt Peak National Observatory, although it had been detected using Doppler echoes before there was no solid confirmation. After the discovery was officially made in 1996, the result was confirmed using an optical light curve analysis, and later confirmed with radar imaging by the now destroyed Arecibo telescope on November 23, 2003. And let's take a moment of silence for Arecibo. Didymos orbits the Sun every 25 months and made a close approach to Earth in November 2003. And when I say close, it was 7.18 million kilometers, which seems pretty far, but for us humans, in the vastness of space, it's very close indeed. Didymos is a K-type asteroid, which are relatively uncommon asteroids with a moderate ready spectrum, shortwards of 0.75 microns, and a slight bluish trend longwards of this. If you are more interested in asteroid classification, we have a video to cover this. Link is in the description. What if DART misses its target? The Earth is not at risk if DART fails its objective, and NASA selected the target with this in mind. DART is due to launch on the SpaceX Falcon 9 rocket on the 24th of November 2021 at 6:20 AM UTC from Vandenberg's Space Force Base. And yes, we are planning to be streaming the mission right here on Total Space. Remember to tune in. Hopefully we will actually see the rocket and not only fog there, as that's pretty common in Vandenberg. DART will spend around 11 months hunting down its target. On the 2nd of October 2022, DART is expected to meet with the Dimorphos asteroid impacting at a speed of 6.6 km per second. The speed of impact does matter here. If you were to gently drop the impactor on the moonlet, not much would happen to its orbit. But if you hit it with several kilometers per second, the impact will have a lot of energy, which can create momentum to change the orbit slightly. And the further away the target is from the Sun, the easier it is to move. Scientists estimate DART's impact should change Dimorphos' orbit period around Didymos by about 7 minutes, which telescopes on Earth will measure and verify. 7 minutes is just 100th of the 11.9 hour orbital period that Dimorphos has. But the collision is more complicated because between 11 to 110 metric tons of the surface could be ejected to form DART's crater into space. This could substantially enhance DART's effect. Depending on the asteroid surface, there are few different estimates how much the orbital speed would change, ranging from 1.75 centimeters per second with no porosity to 2.53 centimeters per second if it's just a rubble pile. And let's take a look at the spacecraft and the science it will do. DART is a low-cost spacecraft. The total mass of the DART spacecraft is approximately 610 kilograms at launch and 550 kilograms at impact. DART carries both hydrazine propellant for spacecraft maneuvers and attitude control, and xenon to operate the ion propulsion technology demonstration engine. The main structure of the spacecraft is a box, but with other structures this will extend to dimensions of 1.8 meters in width, 1.9 meters in length, and 2.6 meters in height. DART is equipped with rollout solar arrays, or ROSA for short. Solar panels are 8.5 meters in length when deployed. These are needed to power DART's NASA Evolutionary Xenon Thruster, or NEXT for short. The engine was developed at the NASA Glenn Research Center, and it's a Pathfinder technology demonstration, and if successful, will prove a concept of technology that NASA will utilize for future missions. As part of guidance, navigation and control, the DART team has developed algorithms called SmartNav, Small Body Maneuvering Autonomous Real-Time Navigation. This autonomous optical navigation system will identify and distinguish between two bodies at the Didymos and then directs the spacecraft towards the smaller body, Dimorphos, all within roughly an hour of impact. To accurately navigate to the asteroid using onboard system, the DART team is leveraging decades of missile guidance algorithms developed by APL. The DART payload consists of a single instrument, the Didymos Reconnaissance and Asteroid Camera for Optical Navigation, DRACO. DRACO is a high-resolution imager to support navigation and targeting, to measure the size and shape of the asteroid target and to determine the impact site and geologic context. The image is acquired by DRACO before the kinetic impact will be streamed back to Earth in real time. In its final moments, DRACO will help characterize the impact site by providing high-resolution scientific images of the surface of Dimorphos. DART will also carry a CubeSat contributed by Agenzia Spaziale Italiana or Italian Space Agency. CubeSat is called LICIACube, Light Italian CubeSat for imaging of asteroids. The DART spacecraft will deploy LICIACube roughly 10 days prior to the DART impact on Dimorphos. LICIACube will capture images of the DART impact, the resulting ejecta cloud, and potentially a glimpse of the impact crater on the surface of Dimorphos. LICIACube has two instruments, LIA, which is short for LICIACube Explorer Imaging for Asteroids, a narrow-field panchromatic camera to acquire images from long distance with a high spatial resolution, and LUC, LICIACube Unit Key Explorer, a wide-field RGB camera allowing a multicolor analysis of the asteroidal environment. DART is a pretty cool mission and historic. After all, we are in a cosmic shooting range, and the protection from the strikes will be important for humanity's survival. The more near misses we have, the more likely we are to have a strike, and DART, like many other spacecraft, advances our understanding of the universe in a new way. What do you think of this mission? Will you be watching along with Total Space for launch? Did we get something wrong? Let us know in the comments below. If you enjoyed this video, give it a thumbs up to show the algorithm you enjoy what we do, so it knows like-minded space nuts will enjoy it too. Thanks for watching. Moro!